Hello, my name is Abdulaziz Ahmed. My student number is 22028843. Today I'm going to talk about how Linux kernel security has evolved from version 4 to version 6. So, our our project called Linux Security Enhancement in Modern Kernels. The main idea is that the Linux kernel moved from basic dictionary access control into a full defense in a depth model. The system now uses multiple layers of security to protect process, memory, and the kernel itself. So this presentation will explain the key improvement that made Linux much more easier security in the recent years. For the second slide, this figure shows the architecture of Linux security modules or LSM. This framework allows the kernel to load different security modules like SE Linux or App Armory, each one enforcing its own security rules. Earlier Linux systems relied mainly on simple permission, but starting from kernel version 4 and 5, the focus shifted towards stronger mandatory access control and system hardening. Then, in kernel 4 and 5 and 4, the Linux team introduced something called lockdown mode. This feature restricted even the root user from modifying or accessing certain parts of the kernel, which improves integrity and protects the system from advanced attacks. Finally, in kernel 6 and above, Linux began to integrating rules to improve memory safety. This reduces entire class of vulnerabilities and enables more fine-grained and efficiency security policies.
We are gonna to briefly explore two powerful and fundamental technologies used to secure modern Linux systems, especially in container and cloud environments: AppArmor and SecComp. These tools are key to reducing the attack surface and preventing privilege escalation. AppArmor, the path-based approach, reversing the AppArmor image. Okay, what is it? AppArmor or Application Armor is a mandatory access control Mac system. Think of it as a security guard for applications. How it's work? It uses path-based profiles. This means security rules are attacked directly to the path of an executable like UCR bin Firefox. It's very intuitive. You specify what files and capabilities an application can access. Example: a profile might simply state that an application can't access network sockets or write to system configuration files. Adoption: AppArmor is known for its user-friendly adoption. It uses simple text files for configuration, making it the default choice for major disruption like Ubuntu and Debian and SUSE. The firewall for syscalls, referencing the SecComp image. What is it? SecComp stands for Secure Computing. If AppArmor restricts what file an application can see, the SecComp restricts what kernel function an application can call. That is the firewall for system calls, syscalls. Attack surface reduction. The Linux kernel has over 400 system calls. Most applications only need a handful. SecComp creates a sandbox by blocking the rest, like mount, patriots, or executives, which effectively neutralizes hundreds of potential exploits. In summary, AppArmor provides an easy-to-manage path-based file and capability restriction layer, while Scomp offers an extremely granular syscall-level firewall that drastically reduces the kernel attack surface. Together,
Programmable security, dynamic instrumentation, and unprivileged sandboxing. We have two methods for programming to increase the security in the operating system like Linux, for example, eBPF and landlock LSM. The slide highlights how modern kernel enforces strict boundaries between user space and the kernel. Uh, for example, lockdown mode prevents both unauthorized modification, integrity mode, and unauthorized reading of kernel memory, confidently mode. Also, we can explain this mechanism with the example like enables unprivileged process like your web browser and your games, for example, to voluntarily restrict their own access right to the file system. And this method, no root needed, any app can use it. And also granular, restrict to specific folders, not all folders in the system. Any app can use it, just general files, not root folders. And for eBPF, a revolutionary internal virtual machine that allows administrators to load custom security logic safety without recompiling the kernel. And this mechanism it have adventures like a verified safety code is checked before execution and dynamic update update policies on the fly. Kernel lockdown mode strengthens the boundary between user space, event root, and the kernel. We have a two mode, integrity mode and confidently mode. For integrity mode, prohibit kernel modification, no unsigned models, no right to dev main folder, and for confidently mode, prevent reading sensitive data, blocks broke keycode, and tracking tools. Hardware hardening, Kessler address space layout randomization, randomize kernel memory locations at boot, making code injection and rob attacks significantly harder by removing predictable targets. Collective impact. Lockdown ensures firmware guarantees aren't bypassed with Kessler raises the bar for exploitation and creating a resilient defense in-depth posture. Thank you for listening. I hope you found this presentation is helpful.